let's go. Hola, ¿comieron bien? Estupendo. Okay, I want to start with thanking all the sponsors for supporting this conference, and I'm really happy to say that my company, BRAINS.ZONE, is also one of them. There's a bit of story connected with this. We wanted to do a custom sticker for everybody to have some kind of little souvenir to remember this conference, take home. But I was busy getting married and I didn't post it in time, and it's somewhere traveling from Italy the last 10 days. But if you really want one and you like the design, just shoot me an email and I'll see what I can do. So, before we talk about React, I want to tell you a story. So, those are PIRAHA people. It's a tribe of Amazon Indians. They live in the territory of Brazil in the Amazon basin, and they are kind of famous. It's not like Brad Pitt kind of famous, more like Dan Abramov kind of famous. Because they are mainly famous among language researchers, and it's for a good reason, because their language is really interesting for a number of reasons. One of them is that they don't really have the concept of deep past, like they cannot say something happened years ago. It means they don't have history, they don't have they don't have common myths, legends. They cannot talk about what's gonna happen a long time in the future. So they cannot talk about what's gonna happen after they die. So they don't have spirits of the ancestors flying around. They don't have religion. There's a set of limitations that their language has, and this is what makes them interesting. For us, like as developers who deal a lot with numbers, it's interesting that they don't count. They have two words. Actually, it's one word that's difference is in the accent. It's like hoi and hoi, and one of them means a little, and the other means a lot. And depending what you are talking about and who you are, it can mean different things. For example, like ask a politician if a 40,000 euro salary is a lot. Like you're gonna get a different answer from somebody on the street. So another thing they don't have is color. If they want to say something is blue, they say it looks like sky. If they want to say something is red, it looks like blood. It's very simple. But we're not gonna talk about the language much. We're gonna talk about their boats, because you see, they live by the Amazon, and there are piranhas in the Amazon, so boats are important. Important for traveling, important for fishing, and general like a part of their everyday existence. So it's interesting when you think about it. They don't really build their boats. Like they buy them from a different tribe. The boats look pretty simple. I'm sure they would be able to do them if they wanted, but for some reason they don't. And amongst this tribe of more or less 200 or 150 people, for the last 20 years, there's a researcher that has been living with them. And he wants to help them live their lives. And one of the things he thought out was, I'm gonna teach them how to build boats. Also, he tried to teach them mathematics, it failed. But he wanted to try to teach them to build boats because it's something important for their daily existence. Like, it's a small tribe, they don't have much exportable goods, they cannot count, trade is difficult, right? So he hired a local craftsman to come to the village and spend time with them building boats, repairing boats, and general construction work. And after some time has passed, the craftsman was sure that they are comfortable doing it by themselves, so he left. And they used the boats that he built for them for a long time, and they didn't really put much effort into fixing them when they break a bit. And when they eventually broken down beyond repair, they did what they always did. Like, they went to the neighboring tribe and bought new ones. And Daniel Everett, the scientist that's living with them, was like, what are you doing? I spent all this effort, all this money to teach you how to build boats, and why are you not building the boats? And they tell him, we are not the kind of people who build boats. So, programmers. This is actual footage from a news report from my hometown. I'll get some water. So it's kind of what I wanted to talk about as if are we like those people because we seem to be so advanced, but there's the kind of mentality that I sometimes see that we're not the kind of people who do something. And this is what this talk is about. But first, let's talk a bit about React Native. So I'm generally not interested in React. Like, rephrasing this a bit. I'm not interested in React as a JavaScript web framework because I don't do web. I do mobile. My whole company does mobile. And I'm really interested in React Native, on the other hand, because the React Native for me is not a framework. It's a game-changing platform. And if some of you spend some time developing native mobile applications, they know that the tools are terrible. I think they are lagging behind the rest of the industry by, I don't know, 3 or 4 years. And if you're coming from like backend development or front-end development to mobile, you're astonished by how they do things. And React Native is a breath of fresh air. Things like hot reloading, things like being able to just send the new JavaScript bundle, except in exchange of compiling building the whole application that takes minutes, increases your productivity so much. And one thing that I especially like about React Native, and it's kind of omitted a lot of times, is that React Native for me is not like a way of putting JavaScript on the mobile. For me it's a platform that allows me to put any language that compiles to JavaScript on mobile, and it's so much of a difference. Like, there are hundreds of them. Back in 2015, I tried to count them, and I found the longest list that I managed to dig up was the CoffeeScript wiki page, and they had more than 300 listed at the time. It was 2 years ago. So, if we have so many languages, the question is, how do we choose the language that we're going to use? And unfortunately, we have this concept of programming language being some kind of tribal identity. Whenever we talk about ourselves as a JavaScript developer or iOS developer or Swift developer, we're not talking about what we do, we're talking about the things that we do not do. For example, if somebody tells you they are an iOS developer, it means they will not build you an Android application because they don't want to. If somebody identifies as a Swift developer, it means they don't like working with Objective-C legacy code bases. And it is much easier and much more beneficial for all of us to think, don't treat it as a badge, treat it as just something that you do. I'm not a JavaScript developer, I'm just a developer who happens to use JavaScript at the time. So this will allow us to be able to accept other languages much easier. So the question is, amongst those hundreds of languages, which one should we choose? So it's very easy, like we're going to use science, like the smart people do, and we're going to figure out how to do it. So the solution is super simple. You take a bunch of experienced developers with some varying skills, you randomly assign them to 2 teams, you give them the same specification, 2 different languages, and wait for them to finish the project, and then you compare, like, which project is better, right? And once you do, you have 1 data point. So you do it 10 times, 20 times, 50 times, like whatever it takes to get a statistically significant result. You see the problem here, right? The experienced developers are kind of expensive. I don't see university doing a research study that takes a project that takes, I don't know, 2-3 months, puts 10 developers on it and runs the study 10 times. It's a huge amount of money. Like, market decides that this time is much better spent than on doing science. They could just as well be working on valuable features that make people click more advertisement on the internet. So it's difficult to make studies like this, but fortunately there is some stuff that we can do by ourselves. For example, let's consider type safety. So, this is a dynamically typed zebra, like in case you were wondering. So, okay. So, what one person did, like I read about it like 2 or 3 weeks ago, is they went through some GitHub issues, probably using the GitHub API, just on the JavaScript projects, and found 400 bug fixes, like simple commits, I don't know, up to 10 or 20 lines of code, most of them around 6 lines of code. And they were looking at those bugs, trying to understand whether, if they would code them on the compile level by some type safety features. Because what they were trying to do was figure out whether TypeScript is better or Flow. But for us, it doesn't matter which one's better. What's important is that out of the 400 issues that they analyzed, 60 of them would be found by these type tools. Exactly the same amount by TypeScript than as Flow. So you would have, if those people were using types in their JavaScript, they would have 15% less bugs. Now the question is like, is 15% a lot or not? Like, everybody saw this quote, premature optimization is the root of all evil. But the thing is that we use this quote whenever we don't want to optimize something. Like, if I don't want to do it, I say, no, it's premature, like it's the root of all evil. But in fact, this quote is longer. The bigger context says, we should forget about small efficiencies, say about 97% of the time. Premature optimization is the root of all evil. Yet, we should not pass by an opportunity in those critical 3%. So, Donald Knuth is trying to tell us 2 things. One is probably we optimize too much in those 97%, and also probably we're not optimizing enough in those last 3%. So, it's interesting, in the paper where he talks about it, he gives a number, what kind of performance improvement matters. And he points at it like 10%. If you manage to change your code, make a performance fix that increases the performance by 10%, you should do it. And so in this context, 15% is higher, right? Also, I think to push this point even further, he's talking about performance of the application. And with bugs, we're talking about correctness. And I think correctness trumps performance almost every time. Let's say you're working on a program that's going to compute what kind of stock you should buy on the stock market. And it doesn't matter how fast the application runs if it gives you the wrong results, right? I can wait a week, like I have no problem with them, as long as it finally tells me what should I buy. So I think this 15% is a really, really interesting and important factor. To give you some other perspective, there's this book Clean Code. I don't know if any of you have read it. They mention Microsoft doing studies on unit tests, and they figured out that writing unit tests finds about 25% of your bugs. So it's kind of close, and we all agree that unit tests are something that everybody should do, right? So another scientific fact, like there was a study done, what are the bugs caused by? And basically, bugs are caused by writing code. It's simple. But what's interesting in what the study found, I think it was done sometime in the 90s, that the number of bugs found is proportional to the number of lines of code, but it doesn't matter the language that you used. So for example, if you're going to write a function in C and it's going to take you 100 lines, and then you decide to rewrite it in JavaScript in 10, it means you'll have 10 times less bugs, which makes it worth, like, you have probably like 10 times slower function, but the bug count is lower. And another thing that a different study has found is that our productivity is kind of constant in terms of lines of code written per day, because it's interesting that if I'm doing, well, let's consider this 100 lines of code C function, and let's consider me, for example, a 200 lines per day programmer. So we kind of know that I will spend half a day writing this function, but if I were to choose JavaScript, it's like only 10 lines, so it's gonna take me half an hour. So we have this clear, we can see clearly the trade-off that like higher level languages give us more productivity, less bugs, and usually less performance. So we talked about the scientific stuff, so now we get to the part where I tell you what language to use, right? Like to switch to use for all the code bases. So it's very easy. Like all the things in the computer science, it depends. Like it would be totally silly for me to try to convince you to use a language that doesn't fit your team. Like the team size matters, the skill distribution matters, the managers matter, the deadlines matter, well, the risk factors of your business. However, what I can do is I can give you a few options that I particularly consider interesting for my business in my line of work. Like I'm doing mobile, half of it with React Native, and the languages that I find interesting for working on client projects are as follows. So first is a super easy, like small iteration on JavaScript. Like we can just switch to TypeScript, you will get rid of 15% of our bugs. Actually, this 15% is like, you can feel it's being pulled out of the air, but if you're not using static typing, you can easily do this kind of experiment on your own code base. Just take a look at, I know, 100 last bug fixes that you did, and ask yourself a question, would static typing solve it for me or not? And then you will have your own number, and you can go to the management and say, okay, I figured out that we're gonna have 20% less bugs if we use Flow or TypeScript or whatever you want exactly. So there's not much effort involved in switching to TypeScript because its syntax is just a superset, and it's fairly comfortable for most teams. And from my anecdotal evidence, I find it really beneficial for different types of teams where we tried it. Much more interesting choice is CLOJURESCRIPT. I know a few teams who are like, they come from Clojure background and they did their backend in Clojure, they did their frontend in CLOJURESCRIPT, and then the product owner says like, you know guys, like we'd really like to have a mobile applications, but we're not really hiring mobile people, like let's do something. And for them, the mix of doing React Native and CLOJURESCRIPT is really popular. There are like two, I think, competing frameworks that are well advanced, and a lot of people use them successfully. The CLOJURESCRIPT ecosystem has a track record of creating really cool tools. And Clojure has one big benefit for me over JavaScript. Like, we don't have types, it's a dynamically typed language, but I think, well, the resulting code, if you write JavaScript into CLOJURESCRIPT, the code is smaller. So we get this increased productivity and less bugs from writing less code. It's a higher level language for me. But my own personal favorite is Reason, that has a sophisticated type system. It has syntax that feels, on the same hand, familiar and expressive, and I feel that it lets me write more concise, more readable code. But I think we have an introduction to it tomorrow, so doesn't make sense for me to talk much about it. I'm sure Patrick is gonna do a great job. So what should you do with all this information? If you could do one thing and just start coding in a random language by yourself. If you don't have time to do it, you can follow our video channel where I'm gonna be talking about it in the next month. Like it's something that's really interesting for me personally, and we also want to share some Reason knowledge in terms of like deeply technical screencasts and comparing feature development with JavaScript and Reason. But basically, what I'm trying to say is that you shouldn't be stuck in this JavaScript developer bubble, ecosystem, badge, identity. And it's so worth it to try to venture out, try new things, learn new things, and become better developers. That's my main message to you. Thank you.
I have good news for you. Your stickers just arrived.
Yes!
So I'm going to hand them out, okay?
Okay, thank you. Any questions in the meantime? No questions? No, just at least once. Anybody?
So, no questions? Someone? Come on, at least one question.
Okay, thank you then.
They like the stickers so much that they don't need to. Thank you.